Alright guys, I'm gonna try and do this video. My mic sucks, so I got super low volume on it. I don't know what's going on with it. It's just crap. Um, anyway, hopefully the volume doesn't drop out too low and you can follow along pretty good with this. So basically what I've done is I've set up replication for my character's input commands. Um, get over into that real quick. Um, basically it's basically this. So switch on authority runs through and it allows you to this executes locally and this executes remotely. So um, when your command comes through, so on this is just mouse pitch. This function here is pre-built into Unreal Engine. It auto replicates. This one auto replicates. Um, this replicates. This replicates. Jump and crouch has its own little replication functions too. So um, they do their own things for movement, pre-built into the character movement class that's part of the actual character class. So I didn't build any of that. That's default stuff. Most of this stuff, well, at least some of it, I'm gonna have to rebuild eventually for my game. But until then, I'm gonna just use its basic components. So after we do our input, we we have to set a variable because we need these variables here, aim pitch and aim yaw, or better yet, axis X and axis Y. We need those for the animation to drive animation. So when we get down into other aspects like is the character jumping, um, is crouching, is prone, and so forth, these will help with the animation aspects because for the state machine we need to know if we can transition, and these variables determine whether or not we can transition. So when I crouch, I set a variable for is crouching, it's boolean to true, and then that tells the state machine for animation that hey, he's going crouch, so let's transition off to a crouch animation and then to a crouch state. So that's why we have to set these variables. Now, they have to be replicated to the server so the server knows that you're crouching so it can simulate you crouching as well. So um, let's actually just look at crouch. So after we do all our local checks, can we crouch? We're going to switch to our authority. We're going to set it with a notify, replication notify. So that's basically if this variable changes, every time it changes, it runs a special function on rep is crouched. And that function actually triggers the actual crouching and uncrouching character movement aspects of things, capsule height, and so forth. Um, and we use the variable itself in animation. So we check if it's crouched. This is all on the authority, so it's local. Then we check if it's prone, and if the character has already set prone, and we unset prone. So you can't be in crouch and uncrouched, crouched and prone at the same time, or prone and then crouched at the same time. So we have to toggle those variables off. So after this runs, the remote side of it runs, and we're running this function, which calls an event. Target is the advanced character blueprint. It's reliable, replicated to server if owning client. So we're calling server set crouch, and server set crouch is this function. It runs on the server only, and it's reliable. And reliable means that the data will get to the server. So unreliable is, yeah, it'll get there maybe, but it's not a priority. It doesn't impact gameplay. So this does impact gameplay, so it has to be set to a reliable. So um, that's what we're doing there. And as far as the notify aspect of that, let's see. This is a rep notify variable. We can just go with standard replicated like is prone, but with this we want to execute a certain functionality once it's once that variable changes. So, and what that actually is this. This is the function. It's called, and we just check it. Hey, is the character crouched? True, we're going to run the crouch function. False, we're going to run the uncrouch function. So this just toggles out the capsule adjustments that we have to do. If you're unfamiliar with that, in a previous video, where did he go? There you go. In my previous video, I walked through driving the capsule. So basically, when you're using in-place animations in Unreal Engine, you're actually driving this capsule. So your movement affects that capsule, and that capsule determines where the size of the capsule, its collision determines where you can go. So as far as like doorways and when you're in a crouch state, whether or not you can get under something. So when I say you're driving the capsule, you're literally driving the capsule. Where's rendering? Not hidden and rendering here. I'm gonna hide the character in the game, so I'm just gonna play in the editor. So see, we're driving this capsule. We're making the capsule move. So when I crouch, we shrink the height of the capsule, and that would be like going, so you could actually crouch and go under something, under a walkway or something like that. So we're driving that. When we jump, we're adding an impulse to the capsule and making the capsule jump up. And the mesh itself, the character mesh, it's pretty much socketed inside. I mean, it's not socketed, but we set its origin so that it's inside that capsule. So wherever that capsule goes, the mesh itself, the physical mesh, will actually stay inside that capsule. And then we use our variables that we set in the movement to actually drive animation, so we get running animations on that mesh inside that capsule and so forth. So that's pretty much how all of that stuff works. So, I mean, that's just a basic overview of what's going on. So, like, where's my jump at? There's jump. Jump function, and then we run a switch to authority because we got to pass these variables off to the server. We need it locally for animation. The server's going to need it for animation to replicate to other players, so other players see your animations when you do them, and so forth. So that's all of that great stuff. So basically what I've done is I've replicated everything off, so we have multiplayer support now. So I can have multiple clients connect to a server, and we can actually see and interact and see the movement and everything. And everything looks really smooth. Before I get into that little demo, what we have up here in the corner, we got the FPS. It says 60. That's the server's tick rate. And because all of this is running on the same computer, when I run the listen server and the dedicated server, they're running on the same box, and along with my rendering client or multiple clients that I'm going to render out. So the actual frames per second, the frame rate that we're going to get is going to match the tick rate across the board. But 60 hertz is what I'm shooting for the final product for production level. So that's what I'm going to be running this demo test out as at 60 hertz. Now, when it gets into replication for the actual character class, right now it's defaulted out to the 100 updates a second. So this says that we're updating the server 100 times a second. And I'm going to change that to 60. And I'm going to change my min update frequency to 30. I'm going to compile that. Well, actually, I want to change that down to like 10. Compile and save it. So we're going to be running it because of our distance to each other in my test. We're going to be running at 60. So we're doing a 1-to-1 ratio. 60 hertz server take rate, 60 hertz client update rate. So that is that. Now, as far as demos go, we're gonna do 2 players, and we're not gonna run dedicated right off the bat. We're gonna run in a listen server environment. So the listen server itself is your box. It's like peer-to-peer. So you wanna host a game, so you're playing as the server and as a client. That's what a listen server setup is. The server's version that's running is actually rendering the client's window. So you'll see that in a second. I'm going to do these in 2 windows here. So on the left here, you have, you'll see it in the top right hand side of the top center of the screen there. It says CS Character Dev Game Preview Server. So that is the server plus it's a client at the same time. So the server's doing double duty. It's rendering the client graphics when a dedicated server does not render graphics. So it's doing that aspect. And on the right side, which is the character that I'm going to use, is the client 1. This is the other client connected. So you have client 0 and client 1. But as you can see, animations are everything's being replicated pretty smoothly in this environment. I mean, it's going to be a little jittery on the left side because I'm running all of this on an FX 8350 CPU. So it's decent CPU, but it's not the best for doing this kind of setup. But you can see that we got everything going on, and you can see the crouch. When I crouch, the capsule shrinks. So that's what one of the main issues was, is getting the crouch to replicate and getting my variables to replicate correctly across the board, because the crouch functionality itself replicates to the server. So you don't want to do double duty replication, saturate bandwidth, and so forth. So we're getting full animations going. So we're good on that. So that's listen server, and it's driving off of its let me see, stats. FPS, yeah, it's FPS. So we can see those stats. That second number under there is the tick interval, time between frames. So we can see all this stuff. Everything is working good. So when I move, it moves on the left. So everything looks good. So that's listen server. It's 60. Now we're going to run this in a dedicated server. So you can see on the left up here, it's client 1 and client 2 now. A little bit better setup. So we should get better performance out of this. And you can see everything. I move on the right, and it mimics it perfectly. Now, the reason why it's mimicking it perfectly is because we're at a ping 0. So what I have to do here is change the pings. So I'm going to simulate my guy with a 10 ping. So now he's got a 10 ping, and you're not going to notice any difference really, because we're dealing with a 16.7 millisecond interval between updates. So before my update gets sent to the server, it's 16.7, depending on when I input it. And then there's that 5 millisecond update travel time latency. So it's not that big of a deal. So 21 milliseconds is not an issue, and you get that movement is good. I don't have all the proper animations set up in this, so it looks a little funky sometimes. So there's no left and right animations set up in my blend space. Got to re-import all those. Now let's take my ping and let's pump it to 50 and see what's going on. Now we're starting to see a little bit of delay. There's a little bit of delay. Square these off. It's just a little bit of delay. It's not too bad, so let's see what 200 looks like. Significantly worse. That's disgusting. And now we can see what 250 looks like. It's even worse. So you see how far it's. Let me get right to the edge. Can't see me here. On the left, you can't see me yet. So I'm going to zip over, and then on the left-hand side, when I can't see myself anymore, I'm going to stop, and we'll see the distance change. Actually, let me restart that, because I'm watching it, trying to watch two different screens here. So this is how far behind cover I am on my screen. And when it stopped on his screen, on the left side screen, it was just right going in behind cover. So let me get this guy up here. And actually, let me take him in the first person camera. Make things a little bit easier. That's some ugly delay, man. So in a peak situation, let me turn my camera on. Yeah, you can start seeing that nasty delay. So see ya, shoot, shoot. So in a peaker's advantage, peak shoot, you're already getting hit before you even see me. But anyway, that's that. So I just wanted to show that to you. And get some of these things all hooked up. So now you're seeing the movement. And let me get this guy back into third person. And you can see movement. Yeah, everything looks good there. So that's the replication, 60 hertz. The client is updating the server at 60 hertz. So, and pretty butter smooth animations going on. I mean, as far as movement, I'm leaving the capsules on in this video so you can see all the movement of the capsule. And when we're looking at the movement, cycling left and right, and just generalized movement, because I don't have all my animations set up, we're using the capsule as a reference between whether or not something's moving in sync and in time. So no desync, so to say. There's no desync in movement, and that's mainly due to pings. The tick interval has that's a delay aspect that contributes, but pings contribute massively to that. So there we go. Replicated movement in a network environment.